Passt schon, ich mach schon.
So, we can continue now with Marco talking about extremely defensive PHP. I'm curious to hear about that.
All right. So, all right. Hello, everyone. It's nice to be here. I didn't know there was a TYPO3 conference in Germany, but I've moved here recently. I'm Marco. I live in Frankfurt. Ich rede Deutsch, but this talk is in English. So, if you don't know my name, this is my nickname on the internet. My primary job is trolling, and as a secondary job, sometimes I'm a consultant. So, this is the avatar for those who don't recognize it. I recently patched it up, so since I do very, very horrible things with PHP, they started calling me Gandalf PHP, so I had to upgrade it. Why is that bar showing out on the left? Oh, Ubuntu. Oh, well, whatever. We'll go with Ubuntu, whatever it does. Anyway, so I work for a company called Rove. We are Zen Framework consultants, and we handle stuff in Doctrine. I'm part of the Zen Framework team, and I'm part of the Doctrine team. So this means that I'm pretty much the bottleneck if you don't see releases. Sorry about that. But today we're not talking about these tools, we're not talking about specific frameworks. What I want to talk about is generally PHP. So hands up, who here is not a developer? All right, so there's a couple people. I hope everyone else does PHP, right? TYPO3 is PHP, right? Yeah? It's all right. It's not all TypoScript. Anyway, so we're talking about extremely defensive PHP. Now, extremely defensive PHP, the title is not, you don't need to be scared of it, but I became an extremist when it comes to code. I don't really take middle grounds anymore, and that's because I'm sick of it. So I became an extremist, and the problem is that I write a lot of code, I review a lot of code, and I fix a lot of code. And every day I put something like 20 to 200 answers on GitHub about somebody stuck with something. So, you know, it kind of forges you. I do way too many projects, and all of these projects do way too much for what they should do. So this means that pretty much everyone that comes into your project goes into the issue tracker and posts a new issue. Why does your project not do also X? Why doesn't it do Y, and so on? And this is very common. It's just because we want stuff, okay? We want it, and it needs to work, regardless if paid or not, we want more. That is pretty much the representation of what is called the feature creep. But so generally, I'm going to talk about aggressive principles, so you don't need to apply them to all your projects, especially if you're doing agency work. I know that you just want to release a website quick, and it doesn't need to be all perfect. But if you're dealing with money, transactions, stuff that can break, stuff where people can die if you make a mistake, please be careful. If you do open source, you don't know where your software is going to land in, so probably one of those scenarios will happen to be true. So these practices work for very long-lived projects. They don't work for that project which is just a landing page that needs to live for a couple of weeks, but they are necessary for projects that are supposed to live a very, very long life. And every open source project does that, okay? Anybody heard of LeftPad? Right? No, never mind. I don't want to know to pick on the Node.js developers. We did these mistakes as well. So please know your limits. This is not for everyone. If you don't like these practices, don't apply them, but I don't see a reason not to do that, except pressure on time at the cost of taking off responsibility, right? So be very considerate about what you publish out there. Not everything that you type on your computer needs to go on the internet, okay? You don't do that with your Facebook stuff. You don't do that with your private pictures. Don't do that with your private software. There is no need for it. So let's start in a bold way. You are dumb. Oh, no, sorry, wrong slide. I don't mean you. Sorry. I am dumb, okay? Everyone is dumb here. Everyone is dumb, and that is because we are still animals. We have a brain which has a limited computing capacity, a limited scope of what happens. Every person can keep in mind at most seven things at the same time, and not very well. Okay, if you have 7 things to keep track of at the same moment, you're gonna freak out. That is your physical limit. And you're going to make a lot of mistakes. And this happens when you have to consider a project, things that happen inside your project. You have to consider a lot of scenarios and things that may go wrong, and forking of processes and stuff like that. And it's gonna be really complicated to track all of that. So you are dumb in a context of knowing all this stuff. You are a tiny entity that can't keep track of all of this. If you think that you know everything, right, then you're probably the dumbest here. If you think, I know how this stuff works, I know how to track all this, and it just works, then you are probably the dumbest here. So, does anybody know about defensive driving? Any BMW drivers? Just kidding. So, defensive driving is pretty much the idea that you are not the only person that is going to make a mistake. The truck driver in the highway is going to go to the left driving lane while you are surpassing them, and a kid is going to cross the street right after a house so you can't see them. Somebody brakes immediately, and so on. So you assume that somebody else is going to make a mistake. You're not a perfect, maybe you are driving in a perfect way, but somebody else is going to cause some trouble. So you can't assume that everything is perfect just because you are doing everything right. There is going to be some problem somewhere. Defensive coding is pretty much like defensive driving, and the problem is that you have to be cautious about everyone's code. And this includes yourself yesterday, and includes yourself tomorrow, because these are different people, okay? I don't remember the code that I wrote yesterday. I don't even remember what I was looking at yesterday. Okay, so every day you improve, you change your way of thinking, you code in a different way. If you look at your code of 2 years ago, probably it looks very different from what you did today or yesterday, okay? And you have to be very cautious about what you wrote in that date and what your code can do to future yourself or to somebody else. So be very cautious about what you write in first stance. So let's grab some references. I'm a bit abstract here, I realize that, but we are going to go into more practical scenarios soon. So some references, books that I suggest, and all the stuff I'm talking about is not new. This stuff has been around for ages, and there's been a crisis in software development in the 70s, in the 1970s, where they tried to figure out how to make software better. I mean, software is not recent, okay? So this stuff was researched before I came here and talk about it. So there's Code Complete 2. This is a bit of an outdated book, in my opinion, because it suggests stuff like don't make a method or a function longer than 50 lines. I'm like, don't make them longer than 5 lines, just to give you an idea. But it still includes some useful suggestions about how you should structure your code so that it actually looks like usable code, and you are going to understand what is going on. The other book that actually forged my career is this one, which doesn't work here. Okay, this is going to happen 5 times during the presentation, I think. So, it doesn't reboot. Good. So this book, called Effective Java. Now, I'm not a Java developer. I just learned some Java. I did some Java applications for fun. But this book is basically a manual of how to build bugs into Java. Okay, this book is full of bugs that you can build yourself in Java, like file access, concurrency, shared memory, null pointers, whatever, you name it, it's in here. Okay, so this book is going to tell you how to break a system and what you did wrong to break it. So I highly suggest that book. Another thing that I want to introduce is a concept which is called poka-yoke. Anybody ever heard of this? Couple hands up, okay. So poka-yoke is Japanese, and I hope nobody knows Japanese here, so I'm going to just lie about it. But the idea is that it means avoiding mistakes. and it means also foolproofing. When you have a factory plant, and you have a machine, and you need to put screws into a washing machine, for example, okay, then it must be very, very hard for the person assembling this machine to put the screw in the wrong location. So it must be already turned in the right direction, there must be one only location where he can put that screw, and so on. This applies also to Lego. Okay, you can't put two Lego pieces upside down and put them together, there is one direction, and so on and so forth. To give you a better practical example, you know what this is, right? This is an RJ45 cable. Anybody ever managed to plug them in upside down here? I had conferences where somebody raised a hand, so. Or people that say that they made an ether killer, don't do that. I hope there's no sysadmin here. But anyway, the point is that there is only way of plugging this in. And this is what the concept of Poka-Yoke is. Okay, there is only way of using it. You can't do it wrong. I mean, it's really, really hard to make it wrong, unless you use a hammer or something. On the other side, to give you a counterexample, this is a device that exists in a four-dimensional space. So you plug it in, doesn't work. Turn it around, plug it in, doesn't work. So now you turn it around again, and then there is some kind of time lock warp opening, and now it suddenly works. So this is maybe not such a good example of Poka-Yoke. On the other side, I must say that it's really, really hard to break this. So at least that got done right. Okay, other concepts to make clear. Code is reusable. Yeah, right? Seems reasonable, right? All right, code is not reusable. Once you take a concept that you have in your brain and put it into code, it is substandard already. You had this idea in your brain that is your ideal world of how it should work. Once you wrote it in code, it's buggy, automatically. It is going to have bugs mathematically. Code is not reusable. Code is crap, like 90% of everything. This is a theorem about literature. So 90% of all literature is crap. So is code. If your code is not crap now, it is going to be crap in 5 years, because standards change. Abstractions are reusable. Abstractions are concepts, things that you can use. In our world of object-oriented programming, abstractions are what we call interfaces, okay? Pretty much. So when you share code with other people, share the abstraction first, and the code needs to be replaceable in every moment. So don't write crap, don't write code in first place. If you don't need to write a piece of code, don't write it. Is there a reason for that code to exist? No? Then don't write it. All right? This thing keeps breaking, so. All right. So what you need to do is you need to first code only for what you need to solve. You have a problem, solve it with code. Don't invent a problem and then solve it. That's what engineers do, okay? And arguably, it's like a big waste of time, and that's why the industry still keeps doing money, at least from our side, from the part of the business. I hope they'll never figure out that. But don't code for your reuse case. You are designing your code to fix a problem. Don't code for something that will come up in 20, 30 years. That is not what you're solving. That is what Matthias was telling you. You're building an abstraction that needs to solve a problem. You're not building an abstraction that is supposed to solve every problem in the world. This is not what you want to do. When you build a video game, for example, there is this golden rule that I learned from Sean McCool, and he said, I don't know where he got this rule, but he said, if it looks right, it is right. Okay, that is really, really interesting. Because when I started coding, I was like, oh yeah, let's build a physical model of particles and stuff and see how we can build a video game of that. No, it's like movies, where you have these buildings and you go back and there's just a piece of wood keeping it up. There is no building, it just looks like a building. Okay, that's a good abstraction. Okay, let's go to good practices here. Let's go to practical code. So, I'm going to assume you write solid code. It's a big assumption. If you don't know solid principles, for which, to be honest, I never remember the acronym anyway, you should at least look them up. Another thing that I'm going to assume, which is a big assumption as well, is that you have some knowledge about object calisthenics. How many do not know about this word? Okay. There are talks about it, and this is a link eventually. So you'll get the slides, there is a link there. Anyway, so I'm going to assume that this is known. These are practices that you should at least read and learn. You want to make at least most of your system as immutable as possible. So what you do is, whenever you have a concept of something in your system that is just a value that is passed around, just model it in such a way that that value can never change. If it is an interest rate object, you just wrap it into a tiny object and make sure that nobody can change those values inside those objects. By reducing immutability, you pretty much reduce all the bugs that have to do with the change of a value during time. That is pretty much what most bugs that we work on are related with. So you pretty much every time you look for a bug, it's always some kind of flag that changed over time, and then you need the debugger to hook in, and then you inspect that value because you don't know how it was there and what happened after that function call and so on. Value changes are pretty much often caused by side effects, and it's a really big mess to debug them. There is a good example of how this got solved. I wouldn't say perfectly, because it's not really immutable, but it's mostly mutable. PSR7, anybody using it or heard of it? Yeah? Heard of it? Come on. Well, PSR7 is pretty much this HTTP abstraction that is proposed by the Framework Interop group, of which, to be honest, TYPO3 is part of as well. So you got a bit of a performance overhead in this, because every time you want to change a value, you create a new object, and the previous one gets garbage collected. And this may cause some problems, especially in a language that is not compiled like PHP. But to be honest, these are usually smaller issues than input-output and queries and so on. What you have to do is to profile your code. There is no like, oh yeah, I'm not going to use immutable code because it's slow. This is just bullshit, all right? Don't do that. Anything you want to have as performant is usually code that is affected, that has a greater impact than all log n, pretty much anything that has to do with sorting, with looping over structures, and so on. For other things, it's not so important. So please profile before saying, no, I'm not going to use immutable code because it's not performant. Other things we want to get rid of. Now, we want objects to be as immutable as possible. This means that we remove setters at all. Setters are a common anti-pattern. Who uses setters here? I use them. I'm guilty as well. Setters do not mean anything. In the original idea of object-oriented programming, objects, as Alan Kay described them, are just kind of like things that interact with each other. Interacting is not copying data from one another. It's I'm telling you what to do and you tell me what to do. But we don't share state, we don't pass each other data. Okay, so this is not what object-oriented is about. Instead, you code interactions, so your objects should have interactions, method that means something for the domain that you're working on. So, this means that now that we got rid of the setters, the only point of injection, at least for services, for entities and stuff like that, is the constructor. You have a constructor, you put all the parameters there, and your object doesn't change over time. This simplifies things by a lot. You don't have to reason about mutability there, and when there is mutability, then you gave it a name. It is going to be user approved by administrator and stuff like that. Approve a user on a user object, or notify user of registration confirmation, whatever. Stuff like that. This is what happens. You don't code setters anymore. You don't say active, set active equal true. Okay? You don't do that anymore. This means that since you have your constructor now, and the state comes in from there, you don't have uninitialized properties. Uninitialized properties are what we usually call optional dependencies. So optional dependencies They look like this. Anybody recognize this? We have a DB connection object. I did them as well. You have a constructor, and then you have a set logger. Now, I use the set logger just as an example of showing why this is broken. But basically, what this allows us to do is to have a connection object that, if a setter is set, if a logger is set, does some logging, otherwise ignores the logging. This is a big waste of time, because it will or will not log, it will be complex to test, and to be honest, it's just more logic than what it needs to do itself. So optional dependencies do not exist. Either it's there or it's not. Do not go in between and say, oh, it may or may not be there. There are two different scenarios here. There is a version of the database connection that logs stuff and one that doesn't. So what you do is you separate them out. But if you really need logging, then instead code it like this. You make a DB connection object, and you say it's always going to log stuff. And then you inject the logger all the time. Okay, there are no setters here. Okay? And then, when you create a DB connection and you do not want to log, then you just inject a fake logger instead. So you remove entirely this responsibility of the connection object to decide whether it should log or not. That is not its responsibility. You just have a fake logger because you're not interested in logging. Okay, so other things to do. Any public method that is not strictly required is not needed. Don't write it. Okay? It's unnecessary because you can find a different way to make it work. Okay? If you have a public method that does one thing and you have another public method that does a similar thing, maybe try to get rid of one of them. Okay? The problem is that once you wrote a public method, you're going to maintain it for the rest of your life. It's pretty much like a child, okay? This is Stefan Priebsch, but basically, this is really, really true. Once you created this method, you can't modify the parameters, you can't modify the signature, you can't remove it, you can't make it private, because consumers of your API, of your abstraction, are going to get a BC break. And this means angry users or customers, okay? And a major version bump. So, other things to remove. Avoid having logic switch parameters. So here we have an example. We have a spammer object. Spammer object is a very common object in our domains, but we have a public function spam, so we send spam to an email address, we pass in some template that we want to render, and then we say, show them the opt-out link or not, okay, as parameter. So what we can do is, basically in here, then there is some decision logic, whether we are going to render this link or not. What we do is we split them out and make them two methods instead, so that the intent from the caller side is much more explicit. So what we do is we split it like this. We have a spammer object. Now we can send some illegal spam, okay, which will not show the opt-out link. And then we can send some apparently legal spam, okay, which has the opt-out link, but we're going to ignore it anyway, and we're going to tell them, oh yeah, we received your request. We're going to probably remove you from the mailing list within the next 72 years. Other things. All states should be encapsulated. So object-oriented programming, whether you like it or not, is about hiding stuff and interactions. So you don't want to tell them what you know, you just let them tell you what they want you to do, and you tell them, yeah, I can't, or no, I cannot, and here's what happened. Pretty much that is what happens in object-oriented programming. And by the way, there is functional programming. I'm not really talking about it here. Functional programming kind of fixed all this by introducing another set of problems. We're not going there. So, we have a bank account object, and we use a setter here. That's just because I want to make the example really simple. So we set the last refresh to a date time where we say last refresh. And then what can happen here is that we have a current time, which is a new date time, and then I say bank account 1, set last refresh with the current time. bank account 2 set last refresh with the current time, and then something happens over time, some logic happens, and then someone somewhere does current time sets timestamp with a new timestamp. And now what you got is a state leakage. You got a shared pointer pretty much, and you got a problem there. Two things are referencing the same object, but that object keeps mutating. So anything that is mutable state should be dereferenced. So to fix that, it's actually really simple to do. So what you do is either you accept a date time and then clone it. This is actually dereferencing. If your date time is not a simple object, but it has multiple nesting levels of objects, you need to make something called a deep copy. And there is a library called deep copy for that, but it kind of shows that something is broken in your logic if you have to do that. Or you inject an immutable object. So as long as you make as much as possible immutable, you're not going to have these problems. So you see, these bugs all get eliminated. You start adding just one of these rules, and many of the others actually go away. Many of the other problems go away. The same thing can actually happen in the constructor. So you have to be very careful about the constructor as well. I'm going to assume that money here is immutable, but you have a date time with the transfer date of that money. You just want to clone it, or you want to have a date time immutable there as well. All right. Any external access to state includes also the subclasses. The reason is very simple. A subclass got written after the parent class, which means that it's a new use case scenario. You have a new scenario that requires some understanding of the problem that you didn't have initially, or maybe you're solving a different problem. So you should make all the state of your parent class private so that the child class doesn't have to take decisions such as, do I access state via getter? Do I access state directly? Do I check this thing? How does the workflow how does the internal state mutate in the parent class if it mutates? And this is really, really common. People have these protected properties everywhere, and then you change the parent class and all the child classes break. Even if those are kind of like private stuff, you should not touch it. So by default, please use private properties. If you make a protected property or protected method, then you need to have an already prepared design of how this property and this method is going to be used. It is simply an API for child classes, but if you do not design for inheritance, then please do not make it accessible. Make it private unless there is a reason to make it protected, and it must be a good one. All right, other things that are interesting. A public method on an object is kind of like a transaction. Let me show you a good example about this. You have a bank account object, and you have an add money method, and then you have a mark bill paid with money. Okay? And what you do, well, these are on the same object. Okay? So what we do is we call it like this. So somewhere in a controller, in a service layer, in a command handler, whatever your architecture looks like, we are going to call these two methods in sequence because they are strictly related. We are adding some money, and then we're saying, oh yeah, this bill got paid. So we're adding it to a log of paid bills. But what happens if add money succeeds, and then mark bill paid with money fails and throws an exception? Right? So now you got some problem there because your state, your internal state, is inconsistent. So you have the money, but you threw an exception, so they gave you the money and you can now run away. Which, to be honest, is positive for a business, but the problem is that these methods are part of a single interaction. They are temporally very coupled. They must happen at the same time, and this is what a transaction is. So what you should do is you make them private, make private this, private that, and then you have a single public function, pay bill. You pass in the bill and the money. Now what happens is that since this is all private API, you know exactly which one of these interactions can fail for whatever reason. So if anything fails here, you're going to write the code to roll back the state. So if there is a state mutation, you're responsible for keeping internal state consistent. And this really makes you paranoid about APIs of your objects, because you now start exposing very, very little public API, because people love to call one method, then the second one, and the third one, like setters, right? So this, that throws exception, right? This happens a lot. Now, often this just causes an application to crash, okay? You got an exception, it just fails, crashes. But if your application recovers, then you have invalid memory, and you're going to have trouble. So this is pretty much how it comes out, and it's much simpler, to be honest. Other things that are very broken in our usual coding is that we assume that a method, when we call it multiple times, is going to give us the same thing over and over and over again. So this is something really common. Took a simple example to show you something that is very, very common. We have a controller, we get the request from the controller, and then we get some parameter called user ID. Simple, right? Then we get, again, the controller request, get user roles. What is happening here is that these two methods, we assume that they will return the same request object. And this is a big assumption. The API does not give us that assumption. At least with our type system, there is no way to enforce that a method is idempotent, so it does return the same thing over multiple calls. So subsequent calls are assuming the same state, but this may break. There is no guarantee that this is true. For example, if we have a clock object and we call it multiple times throughout our application, and our application takes a lot of time to run, when we compare this date-time object with each other, they're not going to be the same. We always have a new one, and microseconds change anyway. So be very careful about them. Instead, well, there is a bug here, but you just cache it in a variable. This has nothing to do with performance. It's about API safety. You cache it in a request parameter here in a variable, so you code idempotence for the API, and then you use it like this. And this will give you a bit of certainty, right? Assertions. Whenever you receive any data that you are not sure about the structure of this data, like, for example, an array. You want an array of strings. You want an array of integers. You want an integer that is greater than 100. You want to assert invariants. Invariants are something that they teach you in like the second week of computer science at university or something like that, so nobody remembers them. But they're really, really useful. So whenever you have an API and you accept a value that is not strictly typed, you want to ensure that it is within the expected boundaries. So you enforce very strict invariants. For example, here is something very horrible that I hacked together, and that's just because I want to do some hackery. But we have an array of wagons, and there is no way in PHP to say that I want an array of wagons here. That's because the type system is very limited. So what I have to do is I have to loop over these values, and I have to verify that they are wagons. So what I'm doing here, I'm splitting it, which is actually doing another interesting thing. This ensures that my array is zero indexed, and that all the indexes are adjacent. So this is actually really interesting. And then I'm type hinting here. So this will break on HHVM, which is also interesting. But in this way, I'm checking all the values for type safety. I'm checking the structure of the array, and all in one shot. So there is no need to do this. There are libraries for doing it. You can just use assertion libraries. I just wanted to make something horrible that looks cool on a slide. But it works on PHP 7, and it's quite fast. So there are libraries for this. There is Eberle assert. There is also stuff by Web Mozart, who is the guy that makes the Symfony Form stuff. Just use those libraries, and you can say, just assure that this array is zero indexed, and ensure that this array only contains integers, and so on. So, but if you have control over the data that flows inside your system, so you're not getting data from the outside, what you want to do is you want to just type hint very strictly. So you don't use mixed. Anybody has at param mixed, right? Yeah, right. That's like, okay, yeah, this is like, sorry for the wording, but this is like at param, fuck you. That's pretty much what mixed means. So here's a good example. One of my sad examples, because I'm probably too German to make happy examples. Like Pivetta and stuff like that, like really creepy. Anyway, so prisoner transfer request, then you have a mixed parameter, so we say this is an alias for whatever. And then we have an access level, and it may be false if no security is needed, then true if some guards are required, then null if it's to be decided, then 10, then 20, whatever. And this is what happens with an organically growing API, and this parameter gets overloaded with more and more and more meaning over time. Because business comes to you and says, oh yeah, we want a quick patch, and this needs to work. And then you keep adding more and more behavior to that single value, because it's some drop-down in your application for some reason. And this is a WTF barbecue. Like, nobody's going to understand how to use this API, and nobody's going to find out a good way to debug this. It's going to be a source of bugs. This is a source of bugs, absolutely. So what you do instead, you encapsulate somewhere, and you say, I have a security level object, which is a value object, and it encapsulates these rules. So you move out this mixed, and you make it a value object that includes those rules that you defined over the ages of your application. So value objects are really, really powerful. In general, and this is something that I learned from Matthias, you can design a system starting just from value objects. You design the entire system from value objects, and then define later, when you get stuck, you start defining entities and stuff like that. But you can really define a system just with value objects, and things passing in value objects and returning new value objects, which is really, really interesting. Value objects are a way of ensuring consistency. So you have to, you pass in some data to this value object, the value object does the validation, and then the type system keeps it consistent for you, which is really, really cool. So whenever you have an API that expects, for example, an email address to be passed in, why pass in a string when you can pass in an email address value object? You know that that value object is going to do the minimal validation to ensure, yeah, this looks like an email address. You don't know if that email address is an email address of one of your users, okay, because it's a value. It doesn't know anything about your database. It just exists on its own. It's a value. But at least you don't need to check if that string looks like an email address everywhere. Just pass it in through. It's in your address space, which means that nobody can tamper it. Nobody can like create an email address object with some invalid data, because it's inside your application. It's not over the network. You're not serializing and unserializing this. You always reconstruct them. So don't use serialize and unserialize on message queue. It's a silly idea. Always revalidate your value objects when they cross boundaries through different memory spaces, which means different running processes. But now you don't need to validate it anymore. You pass it through the layers, and it simplifies your stuff massively. Okay? Same for the return types. Do not return mixed. It is really, really, really an offense to who is going to use your API. You're really, really making them, well, you're making their life harder, and your life as well, because you're going to use that API if you wrote it. Otherwise, why did you write it in first place? All right, so value object again. A good example of this is, who does use Zen validator maybe? All right, Symfony validator. Who uses it? What validator do you use, people? Do you validate data? Sorry? All right. But a good example of this is a validation API. Instead of passing in an array of values and returning an array of values, or passing in a value and returning a value, and then having another getter that tells you if the value was valid or not, and which error messages there were. Instead of doing that, what you can do is you pass in a set of values. Okay, you just pass in a new value set, or a not validated value set, which may be an array or a string or whatever. And as a return value, you get a validation result, And the validation result contains whether the values were valid, okay? They contain the actual values, the valid ones, and they contain the error messages. So you pass in an object, you return an object, and it's very, very simple, and it simplifies things by a lot, okay? Other things that I don't like. Fluent interfaces. Fluent interfaces are very common for query builders and stuff like that, but a lot of people love adding them to all the objects. Now, if you apply the transactionality principle that I was talking about before, there is no point in having a Fluent interface in first place, because you should have a single method call for any state mutation. But in general, there is another problem with Fluent interfaces that is much more, I would say, philosophical. So here are 3 examples. These are perfectly equivalent. These are all valid. I'm not asking you to look for a bug. These 3 all work, and they do the same exact thing. Okay? Now, anybody remember what principle I was talking about initially? Right? No? What is wrong with this? We have 3 ways of doing the same thing. Yeah? Well, yeah, that is true. It is not immutable, but you can't do everything immutable. You have to strive for immutable, that's sure, but you can't do everything immutable. For example, entities are not immutable. A user object changes over time. You can't really make an immutable user object and you have 2, right? But the problem with this is that it's not poka-yoke. You now have your same API, and you have 3 ways of using it. This means that there are 2 ways of screwing it up that are absolutely not needed. Just give them just the rope for hanging themselves only once. Don't give them 3 times the rope. There is no need for doing that, right? So there is only the need for 1 way of doing it. There is no need to make 3 possible styles of coding of the same thing. So this works fine. There is no need to return this, or even the fact that we can't ensure identity on a Fluent interface because the type system doesn't give us that makes it very unsafe to use. Right, there's blog posts and stuff like that. Anyway, other things that I don't like. Make your classes please final by default. Unless you design a class to be extensible, okay, you start from a design and you think, oh yes, I will design this so that the usage of this class is that people extend it and do exactly this. Okay, you need to think about that when you start designing a class that needs to support inheritance. Otherwise, there is no reason to design a class that is not final. Now, every time you have an inheritance, the child class in the inheritance is a different use case from the one that you designed initially. Okay? So, there is a very good rule of thumb to when you want a class to be extensible or not. Now, take your class, which is a user object, for example, okay, and now turn it into an interface object. Okay? So take the class, strip it of all the body, of all the methods, make it into an interface. Now extend the interface with another interface. Okay? So you did this operation. Does your additional interface, the sub-interface, does it add some semantic meaning to the parent one or not? Okay? This is the rule of thumb. So if you manage to find some additional semantic meaning for the sub-interface, then you can use extends. Otherwise, it is not a good idea to use extends. All right? If you have meaning, then you can use it. Otherwise, you just don't need it at all. Again, blog posts and stuff. Traits. Who uses traits? Don't. Please. Traits are an interesting construct. A trait does not exist at runtime, which means that it is a piece of code that is going to be copy-pasted all around your system, which means that if you fix a bug in a trait, you're probably going to introduce a bug in all the other use cases of that trait, because they don't expect the trait to work like that. Because a trait is not an abstraction. Therefore, a trait is not reusable, which is what I was saying initially. A trait is code, and code is not reusable. You're copy-pasting code with a compiler, and we were all excited when it came out in PHP 5.4, and since then, I had no use case for a trait whatsoever. Instead, what you want to do is not really reuse that code with a copy-paste approach. What you want to do is you have to inject maybe a collaborator or have an abstraction that is shared across the other implementation, but it is injectable, and it does solve the problem that you tried to copy-paste into all the other implementations. I found a scenario where a trait maybe makes sense, and I didn't manage to destruct it yet, which is collection APIs, like implementing collection APIs multiple times. But to be honest, I never found a reason to make 3 collections that have the same and have different names. So yeah, we'll see about that. But in general, this is where the dry principle is making more damage than what it is actually helping. So we are coding our code inside the trait so that we avoid repeating it multiple times in the implementations because we don't want to repeat ourselves. But in the end, what we get is just a possible source of bugs that now propagate throughout the code base in a much more extensive way. Right, ensuring deep cloning. I was talking about that early, but basically what can happen is that when you have any cloning of objects, you are pretty much making a copy. Now, making a copy is a state mutation, so you're taking an object, making a new one, okay, and you're copying the state. You're not making a copy through behavior. You're not saying, give me a copy. You're saying, copy this, which means that it's a very low-level technical operation. And if you don't make it right, then you will have shared pointers everywhere. So if you don't clone this time here, you're going to have the same date time bug that we saw before. The other thing that is a bit annoying about cloning is that PHP allows it on everything. So the point is that cloning is an operation that requires deep understanding of the state and the internal components of your objects, which means that your clone operation, while it looks like this tiny, insignificant, and pretty much harmless operation, it may actually do things that were not foreseen before. So PHP by design allows cloning anything instead of saying you can only clone things that are clonable, which is, to be honest, this entire thing that allowing anything to be cloned without knowing how it works internally is kind of a contradiction. So maybe the best solution for this is to disable cloning. Okay? If your object cannot be cloned because you didn't design it for that, then don't clone it. So this is just an example. We have a human object, and cloning humans is legal, at least for now. So it throws an exception. I got other suggestions, which are to just make it private, make the method private, and it will just throw an exception, like you're trying to call a private method. And this is a simple solution to the problem. And this is really, it is just because somebody is going to use your API, and they're going to tell you, oh, I can't clone this object because all my system breaks down. And you're like, why are you cloning it? Oh, yeah, because I can, right? No, you can't. Now you can't. So you broke your BC compliance here, but at least you told them exactly what you want about your objects. Yeah, that is actually yeah, that is a good solution, to be honest. This could be an unclonable trait. But yeah, I'm starting to contradict myself. I need to stop talking now. All right, the same thing happens for serialization. All right? Serialization is a very similar concept. For example, who here uses Doctrine, the ORM? So, anybody tried to serialize the entity manager? All right, it's just an example. But this is what happens, okay? So you have this thing that is not supposed to be saved anywhere, and you're still trying to save it. So it can work sometimes, and sometimes it can't. But this is just because we didn't disable it. But is your object really serializable? Again, you need deep understanding of all the dependencies of your object, and all the dependencies need to be able to be put in a serialized state and in another state on a different machine. For example, PDO does this right. You cannot serialize a PDO connection, because you can't take a connection, copy it into a string, put it in another system, unserialize, and hope that the connection works. It's just not how it works, right? This is just how it is. So again, you need to know about the life cycle of all the data inside your objects. You need to know how they behave. They need to know how they are serialized and so on. So it's a big contradiction. You have moved again from behavior to very technical, low-level state mutation logic. So is your object even supposed to be stored somewhere, or was it never designed for that? Is it something that you can store? Can you store your customers? Yes. But can you store, I don't know, your business logic? Probably a bad idea. Every insurance tries to do that, and they fail miserably every time. So again, throw an exception in sleep. Don't use sleep. I use sleep, but you shouldn't, right? Throw an exception, make it private, whatever. Other things that you can do is serialize only if it's serializable. We have an interface for it. If it's not serializable, then don't try serializing it. But again, you can't expect consumers of your API to not do things. They will do things. They will do bad things to your code, and it's going to be you as well. Okay? You are going to do bad things with your own code. So limit what you can do. That's the only way to actually enforce things. Unit testing. All right, so what you need to do in unit testing is to test every scenario. Anybody doing actual unit testing with every branch coverage? Yeah, old school, that's good. So in general, when you have an API that can branch off into different things that can happen, you want to have a unit test for every one of those scenarios. So all of them, and it's pretty much the idea is that you need to bring the CRAP score below 2. The CRAP score is a ratio between the number of tests and the number of paths inside your code, which means that you will start having much simpler code, because as soon as the paths explode in complexity, you are going to cry. And you also will have a lot of tests, even for simple API. This will make you cry. It will be very, very frustrating at the beginning, but it will teach you to stop implementing every idea you had. It's like reality. It's like, no, all right? So you will love having less features and telling your project manager that you can't implement everything. So here's an example. We have an out service, and the out service allows us to authenticate, returns a Boolean, and throws a bunch of exceptions. And then we have a myLogin functionality, which uses the out service as dependency, and then has a login function, which does the authenticate with some basic credentials, which receive the username and the password, returns true or returns false, and then some stuff here. All right? Let's assume that these are the only branches. How many tests do I have to write for this? Yeah, pretty much. Well, you have to write at least 5, because I didn't show you what this is. All right? But you have to write at least 5 tests. You have to write a test for Boolean true, for Boolean false, for this exception, for this exception, for this exception, and maybe one for generic exception to verify that they bubble up as well. I don't know, the latest one, the last one maybe is a bit exaggerate, plus eventually tests for invalid values here. This is a bit extreme, but that's how it is. Now, if you use a testing tool like, anybody know of Humbug? Humbug, the mutation testing framework? Yeah? If you run a thing like Humbug against a test suite that does not implement all these tests, it will find problems in your code, okay? All right. These were all the scenarios. All right, to recap, these are all suggestions. I'm not telling you this is the way of writing PHP. This looks more like Java, I realize that. Okay, but I don't have a reasoning of saying, yeah, you shouldn't write PHP like this. I can't find reasons against writing code that is secure by default like this. You don't trust any code. Code must be replaceable. What you do is you trust the in the abstraction. You say, oh, this abstraction says returns a Boolean, so I'm going to trust that. But you're not trusting the actual implementation. The implementation must be replaceable at every moment. You want to reduce all the features inside your code to a bare minimum. Solve the problem that you have right now. For the next one, maybe build another abstraction later on. But don't do it immediately. You ain't going to need it. Enforce strict invariance in your code. Your value objects should do that. So convert every value that you upcast via an invariant into a value object. That simplifies stuff. All right? So you await strict values. You return strict values. And I hope that was useful. All right? All right, thank you very much. Are there any questions? We got, I think, 5 minutes.
Okay, in case of XBase, please be careful with value objects. If you have 4 or 5 columns in a table and build it up with a domain model, it will do a where call like this and call like this and call like 5 times.
Yes.
So you have to build an index over them. But
actually, you don't, because if even a partial index is hit, it's going to use just the partial index. If you have an index on 2 columns, it's going to be on that index and then filter the rest of the values from there. So that's what happens, at least in a normal database. You have a filter on 5 columns, okay, and you have an index on 2 of the 5 filter columns. That's not a big deal, usually. Yep.
Should value objects be always similar to strings?
To strings, pretty much, yes. You should have at least a representation that you can push across the network or across storage and stuff like that. A value object is a value, okay? So you can convert it from this to this to this to this. The important thing is that at every conversion you revalidate it. You don't trust it to be valid later on, okay? You just don't JSON serialize and put some values. We have reflection and stuff like that. So that's all there is to it. You just revalidate at every serialization, because that's actually what the value object constructor is doing. You take a string, an integer, whatever, you upcast it to a type-safe version, and this upcast needs to do the invariant check. But yes, you can upcast it, downcast it, upcast it, downcast it, and it needs to move across systems. Right?
I have a question about traits.
Yeah.
Well, the point, I think, is, if I understand it correctly, is don't use traits because you can't trust the code, because the code might change. But so would any third-party code, if you're using an object that implements any kind of interface, but it's not outside of your team, because it's a third-party developer, whatever.
Yeah, no, okay, when you use an interface, you trust only the interface. So when it says Boolean true or Boolean false, you trust it blindly. For example, an interface that says whether a certain email address exists or not in your system, and somebody else codes this for you, and maybe it's a microservice, whatever, some buzzwords, bingo stuff, but you trust it to return Boolean true or Boolean false. And that's all what this API does. You trust the interface, and then the implementation can be rewritten by 10 different companies as long as the interface remains stable. Meanwhile, the trait is just code. There is no specification for it. There is no interface for it. Every time you trust, you modify the trait. Instead of depending on a piece of code, you are importing a piece of code. So if the trait got written by somebody else, then you have a problem. For example, you have a trait with the, let's say, a soft deletable trait. Soft deletable trait that defines how soft deletes work in your system, and you implement it on 20 entity types inside your system because everything needs to be soft deleted. Please don't do that, by the way. Then now, if somebody changes how that trait behaves in a certain point, all right, it's not an API, it's not returning something with a contract, it is actually changes that you imported in your code. So you implemented it on 50 entities, whatever, and one of them somewhere is going to break because you rely on it because it's imported code. So you just trust, it's just code that you copied in and state that you copied in. That's the problem with traits. Does that make sense?
Yes, in a way, but I don't think I don't grasp the difference between like using a soft delete service. Somebody could change the way the service behaves. The interface would be the same.
He could say
will return true, yeah, but it just
Yeah.
deletes everything. Like so,
Yeah.
I have to think about it.
The fact is that the external service may return false at some point, but that's all it can do. It can still only change inside the boundaries of the abstraction. If it changes the actual abstraction, then you have a BC break and you have to adapt your code to the new abstraction. But it can't escape the boundaries of the abstraction itself. That's the point.
Okay, thank you.
Any other questions? No? Beer? No? All right. I can't, I must drive. All right, thank you very much.